Hi everyone. Let's solve an optimization problem involving a box. We must build a box with a square base and an open top. And we have 12 centimeters squared of material available. What dimensions will maximize the volume of the box? What is that maximal volume? Let's visualize this by drawing a picture. To draw a box, the easiest way to do it is to first draw a rectangle, then draw another rectangle and place it slightly to the right and up of the original rectangle, and then connect the corners. Remember, this box doesn't have a top. We also know that this box has a square base, which means the dimensions of the base are the same. Its length and width are the same. Let's call it by x. Let's call the height of this box by y. We must maximize the volume of the box. What we are maximizing is volume. And we know that the volume is computed by length times width times height. In our case, x times y, which gives us x squared times y. We were also given a constraint. We were told that we only have 12 centimeters squared of material available, which means that the area of the base plus the area of all the sides must equal 12. The area of the base is x times x, which is x squared. The area of one side is x times y, and I have 4 sides, which gives me 4xy. And I know that this quantity must equal 12 centimeters squared. For now, I will suppress the units. Let me use the constraint to rewrite my function for the volume in terms of only one variable. Let me solve this equation for y. I first subtract x squared from both sides, and I get 4xy equals 12 minus x squared. Then I divide both sides by 4x, and I get that y equals 12 minus x squared divided by 4x. Let me take this y and plug it in to the formula for the volume. If I do that, I will get volume equals x squared times, and I will have 12 minus x squared divided by 4x. A few things simplify here. I see that 1x here cancels with 1x here, and I get x 12 minus x squared divided by 4. I can multiply out the parentheses here, and I will get 12x minus x to the third power divided by 4. I can simplify this even further by rewriting this as 2 fractions, and I will get 12 divided by 4 is 3, now I get 3x minus 1/4 x to the third power. This is an equation, this is the formula for the volume in terms of x. Let me find the x where this function takes its maximum. To do that, I first name my function by f of x. And I have f of x equals 3x minus 1/4 x to the third power. To find critical numbers, I take the derivative. I get f prime of x equals 3 minus 3/4 x squared. I should also mention that the domain of this function is axis bigger than 0. I cannot use axis less than 0 because remember, x is a side of the base of the rectangle, and that side cannot be negative. So I can remind myself that by saying that axis must be bigger than 0. Now I ask myself, is there a possibility that this derivative is not defined? And is there a possibility that this derivative equals 0? There is no x for which this derivative is not defined. We see that our derivative is a polynomial. You can plug in any x you wish. To determine when the derivative equals to 0, I set the derivative equal to 0, and I get 3 minus 3 over 4x squared equals 0. I moved the term with the fraction to the right side, and I get that 3 equals 3/4 x squared. Multiply both sides by 4, and you get 12 equals 3x squared. Divide both sides by 3, and you get that 4 equals x squared. Take a square root on both sides, and you get that x equals plus or minus 2. Because x's must be positive, only x equal to 2 makes physical sense. It is inside of the domain of our function. That's the only x I will take into consideration. This number is a candidate for where the absolute maximum occurs. Let's check if we indeed have the absolute maximum there by using the second derivative test for absolute extrema. I take the first derivative and I take the derivative of that derivative, and I get that the second derivative is negative 3/4 times 2x, which gives me negative 3 over 2 times x. Remember, the only x's you can plug in are positive x's. Only positive x's make physical sense, which means that this is always negative. This is negative for all x's greater than 0. No matter what x greater than 0 you plug in, this number will be negative. This tells you that your function, original function f, is always concave down. And because that function is always concave down, x equal to 2 must give you a global or absolute maximum, not only local maximum. So I will say here that this means that x equal to 2 gives the absolute maximum. Now, x is 2. What is y? We have a formula for y. The formula for y was 12 minus x squared divided by 4x. Let's plug in x equal to 2 to this expression and see what we get. When I plug in 2 to this expression, I get that y equals 12 minus 4 divided by 8, which is the same thing as 8 divided by 8, which is 1. The dimensions that maximize the volume of this box are x equal to 2 centimeters, the units were centimeters, and y equal to 1 centimeter. We were also supposed to find the maximum volume. Because the volume is x squared times y, x squared is 4 times y, that's 1, which tells you that the maximal volume is 4 centimeters cubed. Volume is given in centimeters cubed.